So integration by substitution. And some people really like this because it feels like a more formal technique for many. So this is where we can't use, or we're told a substitution to use, and we can manipulate what we're told as well. Because if they tell us u is x plus 1, of course, we can also say x is equal to u minus 1. Now, the aim of this is to make an easier integral. So we don't want to integrate it until we've got everything in terms of u and du as well. So we need to replace the x variable to start with, and we need to see how we go. So basically, what we're going to have here, the integral we end up working out, is going to be between 2 and 0, and I'm going to keep them in purple as they're x bounds at the moment. And I'm actually going to replace x with u minus 1, and x plus 1 is u, so I'm going to replace that with u cubed. And unfortunately, I'm still in dx. This is where I'm at. The problem is we've still got a dx and we've still got 2 and 0. Okay, so we need to change a few little bits still here. Okay, so we'll keep going. But hopefully that substitution so far is good. Now, to replace dx with du, what we need to know is since u equals x plus 1, we can work out du dx is equal to 1 and times up by dx. So du equals actually 1 dx. That seems a little bit easy or a little bit too nice, but sometimes that happens. So I actually can swap out dx for du. We also need to change the limits because they were x bounds. So remember, u is equal to x plus 1, and the x bounds we were given were were 2 and 0. So we're just going to add 1 to both of them. So 3 and 1. So basically my converted integral that I now have is I've changed the u bounds to 3 and 1. I have the integral of u to the 4 minus u to the 3. And I'm going to do it with respect to du because du is replaces dx. Okay, so the integral we're asked to carry out is basically that. And because we've changed the bounds, we can literally just do this. It should be a much easier integral than we started with. And if we give that a go and we sub it in, I think, I'm just going to check, 142 over 5 is what we get. Do check it. Okay, cool. So I'll leave that there for us to check. What I am going to do is I'm going to give you a practice run now to try and see how we get on. And then we'll do by parts before we take a break. So here's a practice question. Here's one we can do. And they give you a substitution. They give you this substitution. This is a really good one for you to try. I'm going to give you 3 minutes to look at this. 4 steps, du for the substitution. Trig identities might be helpful. Don't forget the constant. Here you go. 3 minutes. Give this one a go by substitution. The substitution is there for you as well. Another 2 minutes. We'll see how we go. Don't rush, but we'll go through this carefully. So it's quite a nasty one, but let's do our best with this. Okay, we'll go through this shortly together. It is quite a hard question, and there are a few little comments about this for different exam boards, removing certain content. I know, for example, for Edexcel, people have said things like arcsign won't come up. If they give you a substitution like this, however, you will be expected to see it through. So I think this is a really important one to do together. Now, it almost feels like it's harsh for 4 marks, but let's have a little look. So first thing we can actually replace is x for sine squared u. So we can get that in terms of sine squared u. Check we're all happy with that. Now, this is really important because there's square roots, there's identities. 1 minus sine squared u you might recognize as something else. You can also do differentiation. There's lots of different ways we could start frantically approaching this. But straight away, I would immediately replace the x with sine squared u. So the substitution, we haven't always got to put u directly in. Sine squared u is fine. It might be a trig one where u is actually within another function. Now, where we go with this is we also need to sort out the dx bit. So if we differentiate sine squared u, we're going to get 2 sine u cos u. So if we all check we're happy with that. So 2 sine u cos u. Check we're good. And then I would probably times up by du so that I now have something that I can use to replace dx. I can replace it with all of that. Okay, so all of this can replace dx. Okay, now tidying this up further, this is what I have. Now, people get a little bit panicky, sometimes expanding it out and so on. But let's see where we go with this, because now we've got all the right letters. Now, some people will be like, okay, let's use the trig identity. 1 minus sine squared u is, of course, cos squared u. And people get a bit panicky because it's like a different trig function. But that's fine, because we've got a cos squared, we've got cos u on the top as well. And we're square rooting it. So this tidies up quite nicely. So we're going to end up with 2 sine u cos u over sine u cos u. So that's where we get to. So this is going to really, really simplify down to the integral of u 2 with respect to u. It's just putting it back at the end. We've got to be careful because obviously we want the answer back in x. Now, if you integrate 2 with respect to u, you're just going to get 2u plus c. Okay, so the integral is going to be 2u plus c. And of course, we have to put u back in. Now, remember, they didn't actually give us u. They gave us x is sine squared u. So if we rearrange this, we square root both sides and inverse sine it. That's actually what we've just found the integral as. 2 arc sine root x plus c. The answer looks horrible. The integration was really, it was integrating 2. Like, but it was the putting the substitution in that was dreadful. Okay, so I'm hoping that last bit makes sense, but that's why they gave you the substitution, because there's no way you could have just come up with that easily. So that was hopefully the last step is the bit we need to be clear on, and it became from because it was quite a hard substitution. So you